Hello friends, now in this section we will learn how to apply the load on our model. There are different kinds of load that we'll apply on our structure. The first load that we'll apply is the seismic weight. Let me say not the seismic weight but the seismic load. And a second is the dead load, and third is the live load. Okay, so we'll apply these three loads on our structure. The first load that you have to always apply is the seismic load. You cannot apply the seismic load after the dead and live. So if you do that, you will see the error in the analysis. Let us do that. And as I've already told you, also while applying the seismic load, we calculate the base shear using the parameter AH into W. So W will give you the total weight of the building. So AH will talk about the parameters that will define the location of the building, the type of the building, you see the kind of the building, and those things. Okay, the first what we have to do is we have to give all those parameters that we discussed in the previous section into the STAAD Pro, and after that we will give the dead and the live loads, and using these, the dead and the live load, the program will calculate the W. So the program will have AH, the program will have W, and it will calculate a V using these two values, and it will distribute the V into the floors that we call as the story shear. So this is the base shear, and once it will distribute to all the floors, it will be called as the story shear. So let's do that, and let us open the STAAD Pro, and let us go to General tab, and after that let us go to Load and Definition. So first we have to define the seismic parameters, therefore we'll go to the definitions. So you can double click on it, and after that click on Seismic Definitions, and after that click on Add. Now from here I'll select the seismic code that is followed. Okay, so you have to select the code that is followed in your country. So I'll select the Indian standard IS 1893-2002 that is followed in my country. Here we are using IS 1893-2002, but the parameters I will use from IS 1893-2016, and the method of seismic analysis will be based on IS 1893-2016. So it doesn't mean that IS 1893-2002 is wrong. It doesn't mean that. It only means that the 2016 version is improved version of 2002, right? Therefore our design will be better in 2016 than in 2002. So therefore I'll use the parameters from the 2016 code. And if you want to include any accidental load, you can check mark this. And for the industrial buildings, so if your building is an industrial building, you can use you can check mark this and this one as well. So after that you can either enter the values manually, or you can click on generate to generate those values. So all these values will be based on IS 1893-2002. You can still use that code. So if you know the city where your building is located, you can select the city, or if you know the zone where your building is located, you can select the zone from here. For example, if I select the zone 5, the zone factor is 0.36. If I select the zone 4, the factor is now changed to 0.24. Similarly, for the response reduction factor, if it is a SMRF, then it's 5. If you select OMRF, it will be 3. So I'll select SMRF here. And the importance factor, so all general buildings it's 1. If it's the important building, it is 1.5. So I'll select all general building. So rock soil type, I'll take the medium soil, because in Kathmandu the soil type is medium soil. And the structure type is RC building. It's not the frame building, it's a RC frame building, reinforced concrete frame building. Damping ratio is 5%. Now I have to calculate the period in the X direction and period in the Z direction. So I'll do that. So for doing that, okay, I'll change these parameters later also. Okay, let me give zone 5. For calculating the time period, I need to show you this code. So it's IS 1893 2016 clause 7.6.1, 7.6.2, I think. Yeah, so this is for the time period. So TA is 0.09 h divided by root. So the time period calculation, calculation, let's do that. And okay, so time period t in the x direction, so let us do for the x direction. The formula is tx is equal to 0.09 times height of the building divided by root over d, where d is the base dimension. For example, if this is your building, so this will be the value of d, so from edge to edge distance. So let us calculate the d in the x direction. So d here is how much? So let's go to the ground floor and let us calculate the d from this point up to this point. So it's 26 feet. And okay, so it's and also let us calculate the height. Okay, let me just enter the value of the d. 0.09 times, I don't know height right now, it's 26. So if I enter the height also in feet, it will be cancelled out. So let me go to the let me go to the section, and if I calculate the height will be calculated from here. So from here, because we are modeling the tie beam as well, up to the top, up to here. Okay, so you will not include this is the parapet wall, you will not include that. So it's 29 feet and 3 inches. So it's 29 feet and 3 inches. So the height is 29 feet and 3 inches. How much feet? 29 plus 3 divided by 12, it's 29.25. And if I just do the calculation, so 0.09 into 29.25 divided by root over 26, the time period turns out to be 0.52 seconds. So 0.52 seconds. Similarly, if I do this in the z direction, so tz is equal to 0.09 times h divided by root over d. So 0.09, h is 29.25 and d is how much? Let me calculate the value of d. So it's from this end, I think it's already been done here, it's 28 feet. Here also it was 26, so here it's 28 feet. I'll just enter 28 here, and it's 50 second. So 28, if you put, it will be 0.50 second. So 0.52 in x direction and 0.50 in the z direction. Now let's go to STAAD Pro, and so it's 0.52 and 0.50 in the z direction. So if we click on generate, all the values will be assigned here. So zone factor from table 3 you can get of IS 1893 2016. So we'll put for zone 5 it's 0.36, and you have to find where your building is located, in which zone, and from the same code you can find that as well. So response reduction factor is 5. Importance factor as per table 8 of IS 1893 for the residential building it's 1.2, so I'll change it. And rock and soil factor it's 2, and type of structure 1, keep them. So okay, so damping ratio is 0.05 and period is 0.52 and 0.5. So I don't want to give the depth of the foundation right now, and just click on add. So we have given all the factors required to calculate the value of AH. Now these things, the self weight, the member weight and the floor weights, these three options will help you to calculate the total seismic weight of the building. But you know that we have to give the dead and the live load on our beams separately. So I will not be giving these loads here for calculating of the seismic weight. I'll just give these loads in our main window, and I'll later copy those loads so that we can calculate the seismic weight. So you will see these things later. Right now just close this. If you want to use these options, you can use them. Once you learn how to assign the main weights into our beams and the floor, you can assign these loads, no problem on that. But I don't want to assign the same load twice, so therefore I'll just click on close. But you can see that self weight, I'll use the self factor as 1, and I'll not add self weight later. I'll just use right now. So I'll click on add for the self weight, and right now I'll just click on close.